Assignment 1.2 Muscles. In the muscular system, there are three different types of muscles. These are smooth, skeletal, and cardiac. First, I'll be looking at smooth muscle. Well, smooth muscle isn't attached to bones, it uses involuntary movements and most predominantly lines the walls of organs. It can also push fluids and solids through the digestive tract. So, what's the function of smooth muscle? Well, as stated in the previous slide, smooth muscle pushes fluids and solids along the digestive tract and hollow organs and can perform varied functions throughout the other bodily systems. The structure of smooth muscle is that it lacks myofibrils, sarcomeres, and has a smooth microscopic pattern. Also, it's involuntary and it's controlled by the ANS or autonomic nervous system. Now we'll be looking at skeletal muscle. Skeletal muscle is voluntary, it is attached to bone, and it works both anaerobically and aerobically. This means that it works with oxygen and without. The function of skeletal muscle is stimulated to move a part of the skeleton. This type of muscle is voluntary. This means that you control the contraction. The skeletal muscle is controlled by the central nervous system. So when we want to move, the CNS or central nervous system sends an electrical impulse to the skeletal muscle. Structure. The skeletal muscle is attached to bones by tendons, which subsequently help movement to occur in a particular center in the central nervous system or CNS. Cardiac muscle is the third type of skeletal muscle. Cardiac muscle is involuntary. It uses aerobic respiration. This means it needs oxygen and is found in walls of the heart. What's the function? Well, the cardiac muscle pumps blood around the body through involuntary contractions. It also uses the aerobic system for respiration. This is because it is found in the walls of the heart. It has slow contractions to help force the blood through the vessels to the whole body. Structure. There are two different types of cardiac muscle cells. There are pacemaker cells and contractile cells. The CPCs only use 1% of the myocardium, but they exhibit automatically and they establish a constant rate of contraction, whereas CCCs use 99% of the myocardium and tetanus is impossible, and they rely on aerobic metabolism. Functions of the muscles. There are 5 different functions of the muscles, and these are stability, motion, heat reduction, circulation, and digestion. First, I'll be talking about stability. The type of muscle that enables stability are skeletal muscles, and these are voluntary muscles. An example in sport could be a handstand in gymnastics. Without the muscles holding us in place, we would not be able to hold the handstand because we would simply fall because there is no stable base. Motion. Motion is controlled by skeletal muscles. It is a voluntary process as it is controlled by a muscular system. An example in a sport could be in basketball when a player dribbles. With the ball, movement is created by the muscles in the arms and legs to help the player move forward. Heat reduction. Heat reduction is a crucial function of the muscular system. This is because the heat produced enables the body to stay at a stable temperature. The muscles contract to produce the heat, and as much as 70% of the body heat is produced by energy in the muscles. During exercise, the blood takes heat from the core all the way to the working muscles, and it can then redirect it to the skin when the body is too hot. This appears in the form of sweat. The skeletal muscles contract and relax when shivering, and this is also an involuntary movement which can also create heat to warm someone up. Circulation. Circulation comes from the cardiac muscles, which are used involuntarily. There are 2 types of cardiac cells, pacemaker and contractile. Pacemaker cells control the speed of the heartbeat, whereas contractile cells squeeze blood around the body. The cardiac muscles work aerobically, which means they need oxygen. The skeletal muscle pump aids the heart in blood flow and venous return to the heart. Any sport that requires a large amount of oxygen transfer benefits from a more efficient muscle pump. A sporting example would be long distance running, because it requires a considerable amount of oxygen and considerably more than sprinting. Digestion. Smooth muscles provide the body with digestion. Digestion is controlled by the digestive system, which is an involuntary system. This is because when you eat, your body naturally digests. You don't get a say in whether it does or not. An example in sport where digestion is used could be a marathon runner. This is because before a race, they would carb load, which means they'd eat a considerable amount of pasta, potatoes, or rice. They do this because carbohydrates are a form of slow-release energy, so the marathon runner would be able to run for longer, meaning they could set a new PB or break a record. The muscles. Here is a labeled diagram of the muscles at the front of the body and at the back of the body. As you can see, there are many different muscles, and when they all work in pairs, this will be explored more throughout the rest of the video. Origin and insertions. So what is origin? Origin is a bony attachment at the fixed end of the muscle. And this is a diagram of the origin of the bicep. As you can see, it starts at the top of the humerus and ends at the bottom of the ulna. Insertion. An insertion is the bony attachment at the mobile end of the muscle, so this means it's the bit that moves. Here is the origin and insertion of the gastrocnemius. You can see it starts at the patella and ends at the heel. Here are many different insertions and origins of many different muscles throughout the body. For example, you have the rectus abdominis. The insertion would be at the ribs, and the origin is at the pelvic girdle behind you. Another example could be the trapezius. The insertion is the clavicle and scapula, and the origin is at the spine. And a final example would be the latissimus dorsi. So the insertion is at the groove of the humerus, and the origin is at the sacrum. So that the groove of the humerus is moving, whereas the sacrum is staying still. Muscle fibers. There are three different types of muscle fibers. These are type 1, type 2A, and type 2B. Type 1 muscle fibers. These muscle fibers contract slowly and fatigue slowly. They are suited to aerobic activities and require an aerobic metabolism. They have a rich blood supply to provide aerobic metabolism. This makes them perfect for lower intensity activities and over a long period of time. This could be something like marathon running. Marathon running would be good for type 1 fibers because they need the energy slowly. This brings me on to type 2B. Type 2B muscle fibers are also known as fast twitch or fast glycolytic fibers. This is because they contract very quickly and produce a large amount of force. However, there is a deficit. They do fatigue very quickly as well. And they work anaerobically, which means they do not need to use oxygen. An 100-meter sprinter uses type 2B muscle fibers. This is because they need the explosive power in under 10 seconds. Moving on to type 2A. Type 2A muscle fibers contract quickly, but not as fast as type 2B. Type 2A muscle fibers are called fast oxygen glycolytic. This is because they use both the aerobic and anaerobic systems and can exert a moderate amount of force. Sporting examples for type 2A fibers could be middle distance events such as 1500 meters or 800 meters. This is because throughout the stages of the race, the athlete would be needing to use different systems. Here is what I just said broken down into a more simple table. So, how are muscle fibers used in events? So, during different events, the muscle fibers are used in many different ways. A marathon runner would need to use type 1 muscle fibers because they need a slower release of energy over a longer period of time. During a middle distance event, such as the 800 meters, type 2A muscle fibers are going to be used because the athlete would require both types due to the shortened distance. During an 100-meter sprint, the athlete needs to use type B, 2B muscle fibers. This is because they release a large amount of energy quickly and can enable the athlete to get off at a steady start. Here is the data collected from the experiment we had done, and here is participant 1's data. Here you can see this is where participant 1 peaked, and this was his highest power output. His maximum power was 521. Maximum power was 521, and the power drop was 432 watts. This steady decrease here can show that participant 1 was struggling and was mainly using fast twitch muscle fibers. However, it can show that he was able to recruit his FOG muscle fibers, which are fast oxygen glycolytic muscle fibers, to help him. And right at the end here, we could argue that his fast twitch muscle fibers were returning to him because he had used all of them up, and then he was going into his fogs and then his slows, and then his type 2Bs came back right at the end. Here is a comparison between participant 2. This is participant 2, sorry. So this is after exactly the same test. Coincidentally, both people were the same weight, so that worked. And here you can see where participant 2 peaked. And then throughout here you can see where participant 2 decreased. This can imply that they were using their fast oxygen glycolytic muscle fibers, but also the steady sort of line there can show that participant 2 had more slow twitch muscle fibers. And at the end, as it became physically enduring for them, they decreased again. This is probably due to the fatigue level taking place. From the two results, you can see that participant 2 had the higher output of power and also the highest decrease in power. This can show that both participant 1 and participant 2 were working with mostly have fast twitch muscle fibers, muscular contractions. So there are different types of muscular contractions. These are concentric, where the muscle shortens in length; isotonic, the muscle moves and changes length; isometric, the muscle doesn't move; eccentric, the muscle lengthens; and isokinetic, the muscle shortens and contracts at a constant speed. An example of concentric could be a goalkeeper gathering a ball, or someone picking up a ball, and there'd be a concentric contraction at the bicep. Isotonic could be a quadricep when an athlete jumps over a high jump pole. Isometric could be any form of handstand, headstand, bridge, anything to do with the body staying stable. For eccentric, an example could be throwing a cricket ball, because there'd be an eccentric contraction of the bicep again. And isokinetic could be anything, could be running on a treadmill to stationary cycling. Antagonistic pairings. Antagonistic pairs of muscle. In the body, there's many pairs of muscles that work together to create movement. These are called antagonistic pairs. Within the pair of the muscle that contracts, there's called the prime mover, and the other is called the antagonist. This is because it's relaxed. Fixators and synergists also help create movements. A muscle that acts as a fixator prevents any unwanted movement and should normally be found at the end of the muscle. The synergists are able to help a contraction and are predominantly found on either side of the agonist. An example of this could be a simple bicep curl. The bicep is the prime mover, the tricep is the agonist, and the fixator and rotator cuffs with the brachialis as the synergist.